we're going to learn about, I've been told that I need to have better intro. I don't have any good jokes for you. Okay? So, sorry, I got to teach. So if you know that y equals h dx, we're learning about logarithms, then the inverse of that would look something like x equals a to the y. Remember that?
Yeah.
Okay? And so that's all a logarithm is. It's the inverse of an exponential function. So if I were going to graph, this, by the way, is called logarithm. So if I were to graph y equals a dx, it kind of goes like this. It doesn't, kind of goes up, goes through, and it goes up exponentially like that. And it goes through the point, always will go through the point 0, 1. And it will go through the point also 1, a. And it will also go through this point over here, -1, 1 over a. Right? Remember that from when we did exponential functions? Now a logarithmic function, if I were to take a line, let's put arrows on both ends and make it dotted, okay? Let's make it dotted or something like this. Remember, if I draw this line, which has the equation y equals x, and I do a reflection, because you had something like this on your quiz, right? If I do a reflection of this curve over this curve, what I get is the graph of this, okay? And the graph of that is a logarithmic function, and it looks like, I want this, it looks just like this, and it goes up like this. You understand? Okay, so this, where this has the point 0, 1, this has the point 1, 0, because those x and y coordinates flip, right? And where this has the point 1, a, this would be the point what? A, 1. And where this has the point -1, 1 over a, this has the point 1 over a, -1. And where this has an asymptote at y equals 0, this has an asymptote at
X equals 0.
x equals 0. So if you do a logarithmic function and you show that it has a y-intercept, unless it's shifted right or left, it would be wrong, right? Because it never touches the x-axis and goes up like this. And it goes. And what's nice about logarithmic functions is, for very, very big numbers, they go up very, very slow. So they use logarithmic functions a lot to talk about earthquake magnitudes, where you have very high degrees of magnitude, and decibels, where you have very high degree of sound and stuff like that. So so another way to write this same thing is y equals log base a of x, okay? So this and this mean exactly the same thing. So a logarithm is actually an exponent.
Wait,
Yes, sir.
is that x like an exponent or is it like a base?
This thing here,
Yeah.
it's not a, no, it's not an exponent. It's down below. So
I
it's
thought
log base.
is log base x of a equal to a to the x?
Is log, so,
Is it on the same level as x?
no, A is down here. A is called the base,
But
okay?
is x
So
on
where's
top
x?
or next to it?
X is next to it. Okay?
So it's log ax.
Y equals, it's a subscript, so log base A, it's kind of down here. Okay, let's erase
Look at
it.
your note sheet, it says it at the top.
Okay? So that's what a logarithmic function is. So when you're finding a logarithm, you're finding the exponent, okay? You're finding, so in this case it's saying, what do I need to raise a to in order to get x, okay? Which is kind of weird, but we'll do some problems when we get to it. So let's look at your note sheet now, okay? So we can, let me see if there's some other stuff that I need to talk about. For so the one that you have on your note sheet, I think I have these notes somewhere. All right, come on, buddy. Help me out here. Who can do it? Why is it not working? Oh, that's something else. Oh, I could just go right here to my Dropbox. My Dropbox. And I could open up chapter 4. This is 4-4 notes, right? Okay, so now I am. So, looking at your note sheet here, what you have is the exponential function e to the x, okay? And e to the x goes through the point, well, let's get back there. Okay, I have to, I'm trying to write on top of this one. There we go, okay? So this goes through the point 0, 1. It also goes through the point 1, e. It also goes through the point -1 over e. And then this point would be 1, 0. And this point, like somewhere over here, would be what?
E, 1.
E, 1. And somewhere over here would be 1 over e, negative. So this is the natural log function. ln means natural log, and this is e to the x. So natural log is used as the inverse of e to the x. And it's kind of like this. When you do a natural log, what it really means is y equals plain old log base e of x. Okay? So, but this means the same as ln of x. The base is e. But by writing ln, it means that you understand that the base is e. So if they ask you to rewrite something in exponential form, this is called logarithmic form. And to write this in exponential form, I could write this same equation, not this one over here, but this one as e to the y equals x. So this to the this equals this. Okay? So this is called exponential form. Exponential form, and this is called logarithmic form. These are called logarithmic. And if you just have like this, y equals log of x, if there's nothing down there, does anyone know what is down there? There's a 10 down there that's invisible. Okay? So if they just write log like that log button on your calculator, that's base 10 log. So that would be the inverse of y equals 10 to the x. So this is the same as 10 to the y equals x. Okay? So getting to problems like this, change each exponential expression to an equivalent involving a logarithm. So this here, this is the base, right? And this is the exponent. So I could rewrite this as log base what? 1.2 of m equals 3. So this to the this equals this. Alright? So this one, is that an e there? I can't see. So this is like writing log base e of 9 equals, what is this up here? Is that a b?
Yeah.
Equals b, or better, ln of 9 equals b. Because when you have a log base c, it's understood that you can rewrite that as natural log. Got it? Yes?
Suppose.
You suppose.
I don't get the natural log.
Natural log, it's just because E comes up a lot in like real life applications. I think that's why they call it natural log. I'm not really sure. But natural log, it's the same as log, except for the base is E, and E is just a number, 2.73, da 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 da.
Where does that number come from?
Okay, we talked about that in class. 1 over n plus 1 plus 1 over n to the n. Remember that? The limit as n goes to infinity. And it comes up a lot in real life apps and stuff like that. Okay, I want to move on. All right, find the exact cut. Let's go back to this next one. So these should be relatively easy now, I think. How could I rewrite this? Oh, JG4, this is a,
4 to the 5th.
no, 8 to the 5th equals 4.
Oh, yeah.
This to this equals this. This is, what's that, an E down there?
Yeah.
So this is E to the negative 3 equals B. And so you could actually find a numerical answer to this one. This one you can't, but E is a button on your calculator. So negative 3 equals B. I could have also written this again as natural log of E equals negative 3, and it's understood that there's an E there. So to find the exact value of something, you pretend that there's like a Y over here. Okay? So 2 to the Y equals 16. 2 to what power equals 16?
4.
4, right? So Y equals 4. You guys understand where? Yes, sir.
Why does natural log ln rather than nl? Wouldn't it make sense for natural log?
Whoa, whoa. I think because they want you to know that the logs or something. Okay. With me, I'm a pretty healthy guy, so I like to keep my logs all natural. Okay. So again here, so this is like a Y here. 3 to the
I
Y.
have no idea.
3 to the Y equals 1 over 27. So one way you might do this is that you could rewrite 27 as the power of 3. 3 to the what?
3 to the negative 3.
Yeah, you could rewrite this as 1 over 3 to the positive 3, which is equal to 3 to the negative 3. Therefore, Y must equal
Negative 3.
negative 3. So in this case, Y equals negative 3. Did you follow that, kind of? Did I go too fast? Okay. Okay. So then, what time do we get out of here today? 15. So, sorry to disappoint you, John, but we got more time. So I'm gonna, for this one, to look at the domain and range, I'm gonna draw a little graph, okay? Domain and range, and draw a little graph. So if I have, whoops, it doesn't go down like I just drew it, but sometimes it's kind of hard, okay? So the domain of, if this is Y equals A to the X, we kind of talked about this. Domain is
All real.
all real numbers. All real. And the range is, what's got to be true about Y?
Greater than 0.
It's got to be greater than, not greater than or equal to, greater than 0. All right, because it has an asymptote here. And then the if I were to graph Y equals log base A of X, it doesn't cross the line there. I'm just kind of going fast. So if I were to graph Y equals log base A of X, which looks more like this, okay? Its domain, these two things switch. So the domain is now X has got to be greater than 0. And the range is all real. And even though this goes up slowly, it still goes up. It kind of goes up slowly, but it still keeps going up. It doesn't, logarithmic functions don't approach a horizontal asymptote. Okay? So to do problems like this, for any logarithm using this information, x always has to be bigger than 0. So the thing over here has to be bigger than 0. So you write that x plus 3 has got to be greater than 0, which means that x has got to be greater than negative 3. All that? Sure. This one's kind of tricky though. This one's kind of tricky. Do you want me to do this kind of tricky one? Sure you do. Okay. I don't know. I can do this one. I have to grab a picture of it. No. So to do this one, the thing inside the logarithm always has to be that you're taking the log of always has to be bigger than 0. So this, what you have to do with this, you have to say that 1 plus x over 1 minus x has got to be greater than 0. And do you guys remember when we did this at the beginning of the semester? What you have to do is make a little table, make a little number line. Okay? So you make a little number line like this, and you say, you find the places where this function is either 0 or undefined. Where is it 0? At x equals negative 1, right? When the top is 0, the whole thing is 0. And when is it undefined? When x equals 1. Okay? So you put open circles on both of these, and then you do this little test. So at 0, is this thing going to be positive or negative? At 0, is this? If I plug in 0 in here, I get 1 over 1. Is that a positive number or a negative number? It's a positive number. Okay? If I plug in a number bigger than 1, say 2 in here, right? I get a positive number over a negative number, which is what kind of number? Negative number. And if I plug in a number that's less than negative 1, say negative 2, I get a negative over a positive, which is a negative. Okay? So to answer the question, when is this thing bigger than 0? It's bigger than 0 in here. So you would say, I have to say that x is greater than negative 1, or and x is less than 1, like that. Or you could write it like this, negative 1 to 1 with curly brackets on it. Okay? So that's kind of a tricky one. Tricky.
A whole backside.
We still have a whole backside.
Yeah, we got.
We talked about this. We talked about this. We talked about this. Okay? I got a few minutes. Let me talk about this. Vertical, let's just talk about this. Properties of logarithmic functions. It has an x-intercept at 1, 0. A y-intercept, none. A vertical asymptote at x equals 0. You have the points 1, 0. A comma 1, right? And
I thought it was 1.
Yeah, 1,8.
whoops, 1 comma A, sorry. 1 x-intercept. Oh, it's not?
It's the opposite, yeah.
Oh,
X.
isn't it A comma A1?
X-intercept is,
No.
that's right. 1 comma 0. A
It's A
comma 1, right? And 1 over A comma negative. B, don't worry about B.
Oh, 1.
Okay. So to solve stuff like this,
Yeah.
this to the this equals this. So 3 to the 2 equals 4x minus 7. You understand that?
Why did you assign us so much homework?
Because they're like you.
No, you don't.
3 to the 2 equals 4x minus 7. So 9 equals 4x minus 7. I think you can do the rest, right? X equals 4x. Okay, is this an x down here? X to the 2 equals 64. What's x? plus or minus 8. But you can't really have a negative base, so you just use 8. X equals 8. And then the way you want to do this one is natural log. This means natural log. I would rewrite it like this. There's an E down here. Natural log, so 5 equals 2x.
X doesn't equal 4.
It doesn't?
No.
Doesn't matter.
Add 7 to both sides, I get
Yeah.
16 divided
Oh,
by
you
4.
added 7, my bad. I was correct.
So with this one, you have a button on your calculator that is ln, right? So you take ln of 5, and then you divide it by 2, and you get x equals something or other. And this one is in your book. You can look at that
This
one.
is a,
It's a lot of
You're
homework.
studying film, not math.
Mr. Rear, what's your book? Not a big reader.
Domain.
Probably
Oh,
don't
one week
give
you
us
don't
the
need
same.
homework.
Is when you give the most. Jesus, to do that.
This is like 86.
Saturday?
Wait. Saturday.
It's not in best.
Wait,
Oh, that
yeah.
is not.
Just thinking about it.
Oh, I'm going to go this Saturday.
I'm going Saturday.